Hello everyone. Today we are going to discuss about yesterday's JEE Mains question paper with the help of PPT. See, in yesterday's question paper, the first one is what? Which of the following do not decolorize? Okay, the KMnO4 reagent, base reagent. Alkaline KMnO4 solution is called what? Base reagent. So which one cannot decolorize base reagent? Okay, so here C2H4 is what? C2H4 is ethene, alkene. C6H6 is benzene. Okay, so these among these all compounds here, C2H2 is what? Ethine. So ethene, and benzene given here. So ethine is alkyne, ethene is what? Alkene, benzene is what? Aromatic compound. So the benzene, though it is unsaturated compound, does not show the similar properties to that of alkenes and alkynes. So in this case, benzene cannot decolorize what? Bayer's reagent, and also cannot decolorize bromine solution. That point we have to keep in mind. And the second one is the function of anhydrous AlCl3. The function of anhydrous AlCl3, aluminum chloride, in the Friedel-Crafts reaction is to what? So here AlCl3 is what? It is electron deficient species. Electron deficient species meaning what? Lewis acid, electron pair acceptor it is. So electron pair acceptor will always gain one electron pair from the others. It will act as acceptor of electron pair. So Lewis acid it is. Okay. So in Friedel-Crafts reactions, what happens generally? Suppose you imagine CH3Cl. CH3Cl when is taken in the presence of AlCl3, the AlCl3 will take what? Cl minus. From CH3Cl, Cl minus is taken up by AlCl3. Then what will be produced there? CH3 plus will be produced. The AlCl3 will produce what? CH3 plus, electrophile. So what is the function of AlCl3 in that reaction? Producing what? Electrophile. Electrophile is electron deficient species. So E plus, electrophile, will be produced by the help of what? AlCl3. So AlCl3's function is what here? To produce what? Electrophile. Not only AlCl3, but also we use what? FeCl3. FeCl3 is also Lewis acid. So its function also is to produce what? Electrophile. In which reactions? Friedel-Crafts reactions. Friedel-Crafts reactions. Okay. So Friedel-Crafts alkylation, Friedel-Crafts acylation reactions there. Na? In that reactions, AlCl3 will produce electrophile. So that point we have to understand. And next thing is that addition of Cl2 or Br2 means halogen. Addition of halogen in the presence of sunlight to the benzene follows what? So whenever we add chlorine or bromine or any halogen to the benzene molecule in the presence of sunlight, what happens? The chlorine molecule absorbs the energy of sunlight and forms Cl dot and Cl dot. Br dot. The Cl dot is what? Chlorine free radical. So free radicals are produced in the presence of sunlight. So like that here, the free radicals of chlorine and the free radicals of bromine will be formed in presence of what? Sunlight. That is why the mechanism will follow what? Free radical mechanism. So free radical addition reaction takes place. Now free radicals will be added to the benzene. Okay. So the free radical addition reaction takes place in the presence of what? Sunlight. So the free radical addition we have taken. Answer. And next one is that the ratio of sigma and pi bonds in benzene. Benzene has the formula of C6H6, hexagonal ring of 6 carbon atoms in which alternate double bonds are there. So double bonds indicate what? 3 double bonds are there. Na? 3 double bonds indicating how many pi bonds? 3 pi bonds. Now between 6 carbon atoms, 6 sigma bonds there. And to every carbon atom, one H is attached. Sigma bond is there. So one hydrogen is attached with sigma bond, and between all the carbons, there will be 6 sigma bonds. So between carbons, there will be 6 sigma bonds, and also what? Between carbon and hydrogen, there will be 6 sigma bonds. Totally 6 plus 6, 12 sigma bonds are there, 3 pi bonds there. Which ratio they asked here? Sigma bonds to pi bonds. So sigma bonds how many? 12 divided by how many pi bonds? 3. 12 by 3 how much here? 4:1. So 4:1 is the ratio of what? The sigma bonds to pi bonds. Okay, in benzene molecule. Is that clear, ma? So next, see, now it is about first 4 questions, right? Now next one, next question if you take, see here. So the formation of benzene from acetylene. Acetylene formula C2H2. C2H2 is acetylene here. And benzene is C6H6. How many moles of acetylene will be undergoing polymerization to form benzene? Totally 3 moles. 3 moles of acetylene will undergo trimerization. 3 moles are combining now here. 3 molecules of acetylene will combine to each other to form 1 mole of 1 molecule of benzene. That is why it is called trimerization. The type of polymerization in which 3 monomer molecules join to form 1 polymer is called what? Trimerization. So what is that reaction here? Trimerization. Trimerization meaning what? 3 monomers join to form what? 1 polymer. So it is answer what now here? A trimerization. Is it clear, ma? So next here, in nitrating mixture means nitration mixture. In the nitration mixture, HNO3 acts as what? First of all, tell me what is the nitration mixture? This mixture contains what? HNO3 and H2SO4. Concentrated H2SO4, concentrated HNO3 will be present. So this mixture of HNO3 and H2SO4 is called what? Nitration mixture. In this nitration mixture, HNO3, H2SO4 if you take, which is more acidic in nature, which is stronger acid, H2SO4 is stronger acid, HNO3 is weaker acid. When strong acid and weak acid approach each other, the strong acid will produce H+. The weaker acid relatively will gain H+. Okay, so H+ is accepted by HNO3 here. H2SO4 is donating H+. H+ means proton. H2SO4 is proton donor. H+ ion donor. HNO3 is what? Proton acceptor. HNO3 is what here? Proton acceptor. H2SO4 is proton donor. Okay, so HNO3 is accepting proton. So proton acceptor is called Bronsted base. Bronsted base. And proton donor H2SO4 behaves like Bronsted acid. So in this way, in the nitration mixture of HNO3 and H2SO4, H2SO4 donates proton, HNO3 accepts proton. Therefore, HNO3 behaves as what? Base. And also we can say Lewis base, Lewis acid concept. Lewis base, Lewis acid concept. Okay, so simply take here, remember that HNO3 acts as what? Your base. H2SO4 acts as what? Acid in nitration mixture. Okay, that point keep in mind. Next, so your answer is what now? Base. HNO3 acts as base in nitration reaction. Then benzene reacts with dash to yield, okay, benzophenone. Benzophenone first you have to remember. Benzophenone, how to write? C6H5 CO, again C6H5. C6H5 bond CO bond C6H5. Better you have pen and notebook. Pen and notebook, whatever I say that you write question number, then you can write down whatever I'm saying. So for 47th question, what you can write here? Benzophenone. First you have to understand what is benzophenone formula. Yeah, C6H5 bond CO bond C6H5. That is benzophenone. Here one C6H5 group is taken as phenyl group. PHEN. Phen means what? Phenyl. PHEN means what here? Phenyl. And ONE is what? Ketone. ONE is what? Bond CO bond ketone. And benz is from benzene. Benz means for benzene. So C6H5 bond CO bond again C6H5. One C6H5 is taken as benzene ring. One C6H5 is taken as phenyl. Bond CO bond is what? Ketone. So to get benzophenone, now what we need here? C6H5 COCl we need. in the presence of AlCl3. So this AlCl3 will take what? This Cl minus. We know that. So AlCl3 is what here? Lewis acid. So this Lewis acid will take what? Cl minus. The Cl minus is taken up by AlCl3 to form AlCl4 minus. After that, what is left over here? C6H5CO plus is left over. C6H5CO plus. This is what now? Free radical. Sorry, it is electrophile. So electrophile of C6H5CO plus is produced here. This electrophile is produced with the help of what? AlCl3. AlCl3, what here? Taken what? Cl minus na? Therefore, what will be forming? C6H5CO will form. Now in benzene means C6H5 na? C6H5 means C6H5 bond H you take here. Benzene you take it as C6H5 bond H. Now H and Cl minus to form HCl. Then in the place of hydrogen of benzene, what will be substituted now? C6H5CO plus will be substituted. Electrophile is substituted. That's why we get what now? C6H5 bond, CO bond again, C6H5 from this. So we get benzophenone. So this is answer now here. Second option is the answer. Okay. So next here what is taken? CH3CO is taken. In this case, what happens? AlCl3 will take Cl minus. AlCl3 will take Cl minus. After that, here CH3CO plus will form. CH3CO plus. Now what will be structure formed? C6H5 from benzene, CO, CH3. Acetophenone will form. Acetophenone will be forming. But they asked benzophenone here. Therefore, answer is this one here. Okay. So next is that 48th question. In 48th, in the reaction benzene plus Cl2. Benzene plus Cl2 in the presence of what? FeCl3. Okay, to form chlorobenzene plus HCl. The attacking species is what? Attacking species is electrophile or nucleophile, we have to say. Free radical or electrophile or nucleophile, we have to say. So now what happens is FeCl3 is Lewis acid, I told na. AlCl3 and FeCl3 will act as what? Lewis acid. They will take what? Cl minus from this. FeCl3 will take Cl minus first. Then what will be forming? Cl plus electrophile is formed here. Now this Cl plus electrophile will be attacking this benzene. So the attacking species will be what? Cl plus from this. Cl plus from this. The Cl plus is produced with the help of what? FeCl3. So Cl plus will be electrophile. This electrophile will be substituted here. In benzene ring, what is substituted here? Electrophile is substituted. Therefore, this reaction is called electrophilic substitution. Electrophilic aromatic substitution we say. Electrophilic aromatic substitution reaction we say. EAS. Electrophilic aromatic substitution reaction. Is that clear, ma? So FeCl3 will produce what? Cl plus. This Cl plus will be attacking reagent now. Is that clear? So it's about what now here? Option 2 is answer right here. Right answer here. Next, 49th one. IUPAC name of the following compound is what? So in this given compound, benzene ring is attached to what? SO3H group, sulfonic acid group, fluorine, again fluorine. Now fluorine is substituent. Simply it is substituent. And SO3H bond, SO3H is what? Functional group here. Okay. Now what should be given priority? Which carbon to be given first position? So this carbon is what now here? First carbon. The first carbon gets what now here? SO3H group. And it should be taken as what now here? Second carbon. Second carbon. Second carbon is having bromine, fluorine. And fourth carbon is this one here. So this fourth carbon is having what again? Fluorine. So the fluorine is present at which positions? 2, 4. So we say 2, 4 difluoro. Totally how many fluorine? Difluoro. Benzene sulfonic acid. Benzene ring with SO3H is called what? Benzene sulfonic acid. So benzene sulfonic acid is parent compound here. In this compound, what are the substituents now? 2 fluorine atoms at second and fourth carbons. Is that clear, ma? So 2, 4 difluoro benzene sulfonic acid is IUPAC name of this compound. Is that clear? So next, question number 50. So in this case, what they ask, we check it here. Aromatic compounds. Aromatic compounds give smoky flame, because smoky flame meaning what here? When the aromatic compound is burnt, when benzene is burnt, suppose, what happens there? The flame with black colored smoke is observed here. The flame is along with black sooty flame. That flame is called sooty flame. The flame along with black colored smoke is called what? Sooty flame. The sooty flame is due to what? The sooty means messy. Soot means what? Messy in Telugu. So the sooty flame is due to what? More carbon percentage. More carbon percentage in benzene or in any aromatic compound. In any aromatic compound, the percentage of carbon is very higher than what? The percentage of hydrogen. Okay, so due to high percentage of carbon, that will be giving what? Sooty flame. That SO, is soot, messy, is nothing but carbon, one type of carbon particles. That's why what here, the carbon percentage is very high in aromatic compounds. Therefore, the aromatic compounds, when they are combusted, when they undergo combustion, they will produce what? Sooty flame. That point we have to keep in mind. So the carbon percentage is very high. How to calculate carbon percentage in benzene? Suppose you take benzene formula C6H6. Now each carbon, how much atomic weight? 12. 12. So how many carbons? Totally 6 are there here. Okay, so 12 6 are how much? It is 72. Okay, 72 grams of carbon divided by totally how much? 72 carbon plus 6 hydrogens means 6. 6 plus 72, 78. So 72 divided by 78 into 100 will be carbon percentage. So the carbon percentage will be greater than what? The hydrogen percentage. Because of that, the aromatic compounds will produce what? Sooty flame or the smoky flame. Okay. The next one is, now here what is the answer? Carbon percentage is more in this. Here what is the answer in this case? 2,4 difluorobenzene sulfonic acid. So next 51 is what? Benzene is an dash. Benzene is a type of dash here. So it is aniline. What is this? Aniline with how many carbon atoms? 6 carbon atoms. Okay, the aromatic hydrocarbons, some special case of aromatic monocyclic aromatic hydrocarbons are given the name what? Anilines. In that anilines, if 4 carbons are there, 4 aniline. If 8 carbons are there, 8 aniline. If 6 carbons are there like benzene, 6 aniline we say. So answer is what? Second option in this case. Next, question number 52. Preparation of benzene from phenol is dash reaction. Which type of reaction it is? So first you tell me what gives rise to what in this reaction asked? Phenol gives rise to benzene. Phenol gives rise to what? Benzene. So here benzene formula what? C6H6. C6H6. Phenol formula what? C6H5 bond OH. C6H5 bond OH is what? Phenol, right? Now here from phenol C6H5OH, O will be removed with the help of zinc. By adding zinc dust to phenol, the oxygen of phenol will be removed in the form of zinc oxide. The zinc dust will take, zinc atom will take oxygen from phenol. Then what will be there? The C6H5 bond OH becomes what? C6H5 bond H. That is what? Benzene is produced here. So benzene is produced from phenol. From phenol, what is removed? Which atom is removed? The electronegative oxygen is removed. Removal of electronegative atom from the given compound is called what? Reduction. Removal of electronegative atom is called reduction. Removal of electropositive atom is called oxidation. From given compound, if you remove electronegative oxygen, electronegative chlorine, electronegative atom if you remove from the given compound, it is called what? Reduction process. So here from phenol, what is removed? Oxygen is removed. Electronegative atom oxygen is removed from this phenol to give benzene. Therefore, it is what now? Which type of reaction? Reduction reaction. We have to say. Next, the nitration mixture. Nitration mixture means what we discussed earlier. The mixture of which two acids, concentrated HNO3 and concentrated H2SO4. In which what is base? HNO3 is base. What is acid? H2SO4 is acid here. Now here what they are asking here, you see. Nitration mixture is dash. Okay. So here 1:1 mole of molar ratio of concentrated HNO3 and concentrated HCl given. So HCl is not answered. So we have to take 1:1 ratio of what? 1:1 molar ratio of concentrated HNO3 and concentrated H2SO4. Between these two, which is base? HNO3 is base. It is acid. Is that clear, ma? So in this way, HNO3 will produce what? NO2 plus electrophile. NO2 plus is electrophile of nitration reaction. In nitration reaction, NO2 plus meaning what? Nitronium ion. The nitronium ion, NO2 plus ion, is produced from what? HNO3. In the presence of what? H2SO4. So that reaction is called nitration reaction, and the mixture of this HNO3 and H2SO4 in the molar ratio of 1:1 is called what? Nitration mixture. Okay, so option 2 is right answer here. Next, with which one of the following reagents benzene, okay, does not undergo substitution reaction? Benzene does not undergo what? Substitution reaction. Okay, so here fuming sulfuric acid. In this case now here, what will be there? SO3H plus. SO3H plus electrophile is produced here. Okay, that electrophile SO3H plus will be substituted. So they are asking what now here? Do not undergo substitution. Okay, which one? In which case substitution does not take place? They are asking. So fuming sulfuric acid undergoes substitution. SO3H plus will be substituted. And here nitration mixture, in this NO2 plus electrophile will be substituted in benzene. Substitution reaction going on here also. Here also substitution reaction going on. Next, chlorine in presence of light. Chlorine in presence of light. In this case now here, in presence of sunlight, what happens? The Cl2 will dissociate into Cl plus, Cl minus. The Cl minus will be taken by what here? In this case, what now? In the presence of sunlight, what I am saying is AlCl3. In presence of AlCl3 and FeCl3, what happens? Cl2 will dissociate into Cl plus electrophile, Cl minus nucleophile. In presence of FeCl3. But here they ask what now? Light, sunlight. In presence of sunlight, the Cl2 will dissociate into Cl dot, Cl dot. Homolytic division, homolytic cleavage takes place. Here between Cl, one bond is there, na? This Cl has given one electron, this Cl has given one electron. Two electrons are there here. Now homolytic cleavage means what? In the bond, out of two electrons, one electron will go to this atom, one electron will go to this Cl atom. Now each Cl will be Cl dot. The Cl dot is called what? Free radical. So in this case now, in third option, what is happening? The free radicals are produced here. Now free radical addition takes place, remember. The addition of this free radical will take place. So in this case, third option, what is happening? Addition reaction of free radical is going on. But first option, second option, what is happening? Substitution of electrophile is going on. And fourth option, you see, acyl halide, CH3COCl. CH3COCl in presence of AlCl3 will give what? CH3CO plus. CH3CO plus. That CH3CO plus is what? Electrophile again. That electrophile will be substituted now. Electrophile will be substituted in that case. Okay. So in first option, second option, fourth option, what is happening? Electrophile is being substituted. They asked what? Which one? In which case the benzene does not undergo substitution, they asked here. That means answer will be what now? Third option. In third option, what is happening? The free radical of chlorine is added to benzene. That is what now free radical addition is going on there. Okay, man? Next, 55 question number. So C2H2 is what now here? Acetylene or ethine. So acetylene, when passed through a red hot iron tube, red hot copper tube, what happens? Benzene is produced here. Now A is what here? Benzene. Now this benzene is made to react with what? Fuming sulfuric acid. Fuming sulfuric acid. In this fuming sulfuric acid, the reaction of benzene A with fuming sulfuric acid is called sulfonation. In sulfonation reaction, what happens? SO3H plus electrophile will be substituted in benzene. Then benzene will convert into benzene sulfonic acid. So B is produced from A. A is what? Benzene here. Benzene undergoes sulfonation to give B. B is what now here? Benzene sulfonic acid. Benzene sulfonic acid. That is C6H5 bond SO3H. C6H5 bond SO3H is called what? Benzene sulfonic acid. So answer is what now? B is what now here? Benzene sulfonic acid. What is A here? A is what? Benzene. Is that clear, ma? So this reaction is what now? Acetylene to give benzene. Acetylene to give rise to benzene is what? Polymerization reaction. That is exactly trimerization. Trimerization reaction we say. Okay. Now next, 56th one. CaC2 means calcium carbide. In this year, C2 minus 1, C2 minus 2. The C2 will have what? Minus 2 charge. C2 minus 2 and Ca will be having what? Plus 2. The Ca will have plus 2. The Ca plus 2 and C2 minus 2. So Ca is having what? Plus 2. Now here water is what? H2O. In this H2O, H plus and OH minus will be there. H plus and OH minus. Now OH minus will be taken by Ca. Calcium hydroxide will form. Then H plus ions will be taken up by C2 minus 2. Each means C2 minus 2 will take 2 hydrogens, 2 H plus ions. Then H2 and C2. H2 and C2 will form here. So what is the compound here? A is what? C2H2. A C2 there, H2 from water. So C2H2 will be forming. Acetylene is formed here. Again, acetylene is passed through red hot iron tube or red hot copper tube to give benzene again here. Benzene is produced here. Again, this benzene now, this benzene is made to react with what again here? Sorry, just a wait. Just a moment. Again, so benzene is made to react with what now? CH3Cl in the presence of Lewis acid. In the presence of Lewis acid, what happens again now here? The CH3 plus will be substituted. The CH3 plus is substituted, electrophile is substituted in benzene. Now CH3 and benzene ring. So C6H5 benzene ring plus bond CH3 is what? Toluene. So what will be forming here? So here B is what now here? Benzene. B is what? Benzene. And C is what here? Toluene. Toluene means what? C6H5 bond C6H5 bond CH3. So C6H5 bond CH3 is called what now? Toluene. Okay. So like this benzene and toluene will be formed here. Benzene and toluene are formed. And this reaction is what now here? Friedel-Crafts alkylation. Here methyl group is substituted now, so it is called methylation. We say. Next. So what is X in the following reaction? What is X in following reaction? Now here what is taken reactant substrate molecule is what now here? The substrate is C6H5 bond C triple bond CH. C6H5 benzene ring bond C triple bond CH. Here now see Hg plus 2 ion and H plus ions. H plus ions from sulfuric acid, dilute sulfuric acid, HgSO4. HgSO4 will produce what? Hg plus 2. So HgSO4 and H2SO4 in presence of these reagent, this reagent, what happens now? In the presence of Hg plus 2 ions and H plus ions, now water will be added to this. What will be added? H2O will be added. What will be added? H2O. So H2O is what? Water here. H2O is what? Water. The water is added to what? Water is added to what? This compound here. In this case now here, the two hydrogens will be added to the unsaturated carbon with more hydrogen atoms. Okay. So here this unsaturated carbon with one hydrogen. This unsaturated carbon with 0 hydrogens. Already this carbon has 3 bonds and a single bond. 4 bonds already there. No hydrogens on this carbon, right? On this unsaturated carbon, triple bonded carbon, 1 hydrogen is there. Now what happens is that in this reaction, the H2 will be added to 2 hydrogens will be added to the triple bonded carbon with more hydrogens. So the CH becomes what after adding 2 hydrogens? CH3. And this oxygen will be added to the unsaturated carbon with less hydrogens. So here it is 0 hydrogens here. So to this carbon O will be added. A C double bond O is formed here. C double bond O. So what will be compound now formed? C6H5 bond C double bond O bond CH3. So what is the compound formed here? C6H5 C double bond O and CH3. So this compound is produced here. So it is what now again acetophenone. A phenyl group na C6H5 is phenyl. CH3 is acid. One is what? Ketone. So acid, phen, one. Acetophenone we say here. This compound is produced here. Okay. Next reaction, 58th one. So benzene is a dash molecule. Benzene is a dash molecule, they ask here. Is it tetrahedral or planar or trigonal or square planar? What is the type here? Planar structure here. Benzene is what? Planar molecule. Every carbon atom in benzene undergoes what? sp2 hybridization. sp2 hybridization shape is what? Geometry is what? Trigonal planar. Trigonal planar geometry. Every carbon. So benzene has what? Planar structure. So what is the answer here? Second option is the correct answer here. Okay, man? So next one, the 58 already we discussed. 59. Here anyhow planar. Okay. So next one, benzene contains what? Double bonds. Benzene contains what? Double bonds, but okay, does not give addition reactions because benzene has double bonds. Okay, why it is not showing addition reactions like alkenes? Alkenes have double bonds. They undergo addition reactions easily. Benzene also has double bond, but it is not undergoing what? Addition reactions easily. The reason what they ask here. So what happens is that the resonance will occur here. Resonance why? In benzene molecule, alternate double bonds there, na? Pi bond and pi bond at alternate position. Whenever pi conjugation is there, what happens there? So the delocalization of electrons will take place. Shifting of pi electrons in the benzene ring takes place. That is called resonance. The resonance will decrease the energy of benzene molecule. The resonance means the shifting of electrons, delocalization of pi electrons in the benzene ring will decrease the energy of benzene molecule. Whenever energy decreases for the benzene molecule, the stability increases and leads to greater stability or greater stabilization. When benzene gets more stability, it behaves like saturated compounds, alkanes, and undergoes substitution reactions. Instead of undergoing addition reactions like unsaturated compounds, the benzene, because of its stability by resonance, it will show interest to show what? To exhibit what? Substitution reactions. Okay, man? So this is answer. Now, third option is correct answer. And the 60th, the last one. Which of the following is expected to be aromatic? So whether the given compound is aromatic or not, to say aromaticity, we use which principle, which rule we use here? Huckel's rule we use. 4n plus 2 rule. 4n plus 2 rule or Huckel's rule we say. So according to Huckel's rule, the number of pi electrons in the given species, we have to take it first. Now number of pi electrons must be made to equal with 4n plus 2. Then n value we have to calculate. If n is an integer, that molecule is what? Aromatic. If n is not integer, that molecule is not aromatic. That point keep in mind. And second condition what? The given compound should be cyclic structure. Another one, the given compound should be planar in geometry. Planar means what? All the carbons must undergo sp2 hybridization. All the carbons must undergo sp2 hybridization. sp2 hybridized carbon has what? Which geometry? Trigonal planar geometry. To show planarity, the carbons must be sp2 carbons. Now check it here. In fourth option, if you check, in fourth option, how many pi bonds are there? 1, 2, 3 pi bonds. Here 2 electrons, 2 electrons, 2 electrons, 6 pi electrons there here. So we say 4n plus 2 equals to 6 pi electrons. N equals to 1. N equals to 1 indicating what here? It is integer. So this is aromatic compound. Huckel's rule is satisfied. Okay. Now next one is that odd number of pairs of pi electrons should be there. Here one pair, pi electron pair, pi electron pair, pi electron pair. Totally how many pi electron pairs? 3 electron pairs. That's why here 3 pi electron pairs indicating odd number of pi electron pairs there. That is one condition. And next one, cyclic structure it is. Cyclic. And planar structure means all carbons must be sp2 carbons. Means every carbon atom in the ring should be having the pure p orbital. Pure p orbital should be there. In sp2 carbon, one s orbital mixes with 2 p orbitals, and then what will be left over? One pure p orbital is left over. The pure p orbital will be present in what? sp2 carbon. So all the carbons must be sp2 carbons. Now check it here. Here this carbon has 2 bonds on either side and 1 bond with what? Hydrogen. One bond with hydrogen already there. Already hydrogen is there here. Imagine here. So this hydrogen is there. So this around this carbon, how many bonds now around this carbon? 1, 2, 3 bonds there around this. Now plus charge is there. C plus has how many single bonds? 1, 2, 3 single bonds. So this type of carbon is what sp2 carbon. sp2 carbon means one pure p orbital will be present. Here every double bonded carbon also sp2 carbon. Every double bonded carbon is sp2 carbon. So all the carbons in this molecule, in this molecular species, is what sp2 carbon. Every carbon is sp2 carbon. Therefore, it is what fulfilling all the conditions of aromatic character. So this compound is taken as what aromatic compound. Now, why this compound is not taken? You check it here. If you take this carbon atom, this carbon has how many single bonds around it? 1, 2, 3, 4 single bonds. So it is tetrahedral geometry. Means sp3 carbon it is. sp3 carbon is not planar. Tetrahedral geometry is not the planar geometry. So this molecule is not the planar molecule. That's why it cannot show what. It is following Huckel's rule. 6 pi electrons there. 4n plus 2 equals to 6 and n is equal to integer only. But it is not following what? All the conditions of aromatic compound. So we take fourth option as what? Aromatic species. Is that clear, ma? So this is what it is to be understood. I will send this PPT. Please go through it and do it once again. First one we did not. And the first case here, what is the first option here? 41, what is the answer? Benzene. And 42, what we discussed to produce AlCl3 function is to produce what? Electrophile. And addition of Cl to Br in presence of sunlight is what? Free radical addition. Free radical addition. The ratio of sigma bonds to pi bonds in benzene what? 4:1. So I will send this PPT. Please go through it. Okay, ma. Bye. Good day.